Hello! Today we are going to be talking about quadratic functions. A quadratic function is a function whose degree is 2. In other words, it's a function that has an x squared in the problem. The shape of a quadratic function is called a parabola. That means it's going to look like a U shape, or it might look upside down like a hill. Please feel free to pause this video or re-watch it as many times as you need to so that you can understand the material. Quadratic functions have something called a vertex, the highest or lowest point of a parabola. This picture shows where the vertex is located in a parabola that opens up or in a parabola that opens down. In this parabola, this point right here is the vertex. It's the very lowest point. We call the lowest point the minimum. In this parabola, the vertex is located here. It's at the very top. When it's at the very top, we call it a maximum. Let's try an example to see if we can't find the vertex of a parabola given its graph. Here's the graph of a parabola. And we see that the vertex is opening up, like this example here. So we know that the vertex is going to be located at the very bottom, right here. And we label the vertex as a point with x and y coordinates. In this case, x is 1 and the y is -2. So we would say that this is the vertex. 1, -2. There's your vertex. Parabolas also have something called an axis of symmetry. An axis of symmetry is an imaginary line that divides the parabola into two equal halves. This picture right here shows an example of both the vertex and the axis of symmetry. As you can see, the vertex is located at the very bottom, and the axis of symmetry is a line that you can take this parabola and fold it across the line, and each side would match up perfectly, so each side is identical. This axis of symmetry, in this case, is at the x value of 2. So we would say x equals 2 is the axis of symmetry. Let's try finding the axis of symmetry in this example. In this example, we already found the vertex right here at 1, -2. And then we can see that the axis of symmetry goes directly through that point, cutting the parabola exactly in half. So we could fold the parabola directly across this line and it would match up exactly. This line, the equation of this line is x equals 2. X equals 1. So in this case, x equals 1 is the axis of symmetry. Not hard to find when you look at the graph. Now, the next thing that we're going to want to do is decide if the parabola is going to open up or down based on the equation. To make that decision, you're going to look at the a value when you're looking at the equation. When I say a value, I mean it's the number attached to the x squared. If that number is positive, then it will open up. If that number is negative, then the parabola will open down. In this case, the number attached to the x squared right here is -2. So since the a value is -2, we would go over here and say, look, it's negative, that means it's opening down. Now, the other thing that we can decide from the equation is whether the parabola will be wide or narrow. To decide if the parabola is wide or narrow, again, we're going to look at the a value. And then say, well, if the a value is bigger than 1, it's narrow. If it's smaller than 1, it's wide. In this case, we found the a value to be to be -2. But we already saw that the negative implied that it's going to open down. So then we only have to look at the actual number part, not the sign on the number. And in this case, the number is 2, and since 2 is bigger than 1, we would say that this parabola will be opening down and narrow. And you can check that by looking at the graph on your graphing calculator. Hopefully this can help you work through some problems regarding quadratic functions. Please feel free to watch this video again.
John Cornwell, please come to the office. John Cornwell.